Good morning, everyone. Good afternoon, and welcome to the breakout of your monolith webinar. Thanks for joining. First of all, spend some time with me. In the next 45 to an hour, we're gonna go through a quick review of benefits and challenges of microservices architecture. We're not going to spend too much time into details about the journey, why to do it, why not to do it, because there is plenty of information out there, great books that you can refer to. But this is going to be like just a bit of overview of what are again benefits and challenges. Then we're going to see a few points to be focusing on when you are planning your journey to microservices. And we're going to also see like some of the most used and recognized patterns for these migrations. And most of the session will be about like a hands-on live demos. So finger crossed that everything is going to be smooth. And we're going to use, in this case, Amplication, but doesn't matter. It's just to visualize and do code changes to achieve and implement one of those patterns that we're going to see. There will be time for Q&A as well. If you have any question anyway, just pop in the chat. I'll try to answer as I go. For any question that are not answered, we will try to answer offline, or like reach out by email with the answer, or organize like a session if you want one. So let's dive straight into the webinar. So straight to the point, benefits and challenges of microservices. Is not being comparison with a monolith, to be honest, because we want to just focus on a decision to go to microservices at this point. There are a few benefits. Here are actually grouped into two macro areas, the more technical ones on the top and the more business-focused one on the bottom. And of course, we have the counterpart challenges for each of the benefits as well. So as you all know, scalability is probably one of the highest, easiest to see benefit in microservices. You can scale services independently. So that means you can have an efficient utilization of your resources in production or in any environment. This was also going to affect your cost, efficiency. You will be able to improve your fault and resilience, fault isolation and resiliencies. In this case, one microservices fails. That doesn't mean that the entire application is going to be impacted, but the disaster can happen in just an area of your system, not affecting the rest of the system itself. You can achieve a great technology diversity. Sometimes this is a reason to go to microservices or to start new services. Sometimes it's just a good benefit that comes with the choice of a microservice architecture. What does it mean? Well, imagine the scenario where you have to implement a new feature or a new set of feature in your system, and the technology you're using currently for your monolithic application doesn't really cut it, right? Doesn't make the cut. An example, you might have all of your backends written in Node, and now you need like a proper ML focus feature where you would have chosen potentially Python and other more mature framework out there. Well, with microservices, you can just pick it up and choose that one in your new microservices. You're gonna get a better data security and compliance. That's kind of by nature, because each of the microservice will, if they were actually well architecture and design they will only have access to their own data. And in this case, only applications that own the data will be able to access it. And imagine that one in case of new security vulnerability happens to get discovered. People try to leverage those. So like an npm package, if we stay in the Node realm, through an npm security vulnerable npm package, you get deployed to production. If that was part of a monolithic application, you would have access to a lot of data. In this case, that would be focused and only thankfully borderline grounded to a specific area, but it's better not to have that problem anyway. You will have a better and a faster time to market. Of course, breaking down an application into smaller independent pieces, it means also quicker development and deployment. I will not be the first one to say that. It will allow you to have a better business agility in terms of able to scale out teams in this case, or just features, right? With more freedom. You will not need to handle all of the complexity of delivering a new feature through a big monolithic application. And last, in this case, some of the benefits is, of course, the team scalability and autonomy. Being able to own a specific feature or set of features in a system and be able to deploy them without the need to interact or to wait for other teams on the same monolithic service, that is a big benefit, right? You can just do it out of the box. There are also challenges, as you all know. The complexity that comes with distributed system is definitely higher compared to having a single application. There are also of course, there are systems out there that will help you out in reducing or being able to manage this complexity in a much easier way compared to a few years ago. But that is something that we always need to notice. Service orchestration and coordination now is a thing. When you have one service, you didn't really care about it. If you have now multiple services, you need to know how they will interact and how they will be running. Again, there are systems out there that will take the service orchestration out of the problem and complexity out of the game, and you will just leverage those solutions that could be, from the most known Kubernetes system to, cloud-based unique feature like ECS or Cloud Run for GCP, for example. In terms of challenges, we can see here also testing and QA. Testing is also a benefit in microservice because you're going to test more quickly and more in isolation out of the service that you have. I put in challenges just to focus on the end-to-end side. Of course, when you have one service, it's much easier to perform an end-to-end test. When you have multiple services, you need to coordinate the environments where all of those services will need to be in order to perform a complete end-to-end test. Security authentication. In this case, security authentication with monolith, it was handled by one unique service. Now you need to have a unique approach and a unique strategy for authentication and security of your services. That can be, on a different level, or it can be just leveraging system like pattern or framework like single sign that allow you to have single sign-on, right? Where your services will just gonna leverage and trust the token that will be given to them. And last, from the technical challenge, is definitely the local developer experience. Running one application on one developer machine that comes with everything sometimes it's just super easy to set up. Don't be worried, because with microservices, you got benefit in that side, even though you need to know a bit more about the distribution of your services locally. But the benefit is that you can run only the service that you need to work on and not the entire system. So you might end up having a lighter developer experience, even though it needs to have more knowledge about it. Monitoring and troubleshooting could be a challenge if not handled correctly. There was a topic webinar that we ran a few months ago about open telemetry and distributed tracing. That is absolutely some of the must solution that you want to go for when you go in microservices, because that will allow you to have still the same one panel of one central view of your trace and monitoring and logging that you used to have with a monolithic application. And of course, other challenges like discoverability and governance. You need to take care of potentially service catalog in this case. Depends on the size of your organization, you might need more or less governance on that side. But there are other tools out there, again, that you can leverage for it. Reporting is just about, is kind of the counterpart of better data security compliance. Data is more compared like groups and like blocked in silos, let's say. So to have a proper reporting, you will probably need to have solution that will kind of connect all of that data together to still achieve the same amount of reporting you used to do. And last but not least is the team communication and collaboration. In this case, is mandatory. People cannot just look at just the code, even though monorepo solution might allow you to do so. You need team communication to be able to organize, QA, like end-to-end, deployment of feature that might touch multiple services and so on. But let's say that you already know the benefit, you're ready to go on board of it. Where do you start? Well, migrating from a monolithic architecture to microservices is quite a lot of work, and you always need to take it. Your journey needs to be really carefully planned, and a really good plan needs to be really well executed as well, right? There is no one solution that can fit them all. So I'm not gonna here say you have to do it that way. I'm gonna show you like potentially some point that you can start from. And as I was saying before, some common patterns that you can leverage. But of course, it will all depends on the complexity and the size of your monolithic application that you need to migrate. You need to take care also the technology stack, for example. You need to take team expertise, business requirements. So it's always like, it's a mix of all of those variables when you do your planning. But where to start? Well, one of the obvious way to start is to define your boundaries, your system boundaries, your domain boundaries in this case. And this is part of the, the assessment and the planning side. This usually comes as, domain-driven design pattern as a great solution to do so. There are like workshop and way to achieve this without even like opening any line of code, like event storming, for example, is a great framework you can workshop you can do, but it's purely based on, post it on a wall, old style. But this will allow you to know how you're gonna cut your microservice system, right? And these domains are actually business domains that are not technical. They don't need to be technical at all. So sometimes the division doesn't need to be technical. So it's really important to nail those down as soon as possible. Another point I will actually point out quite strongly is to define common patterns and standards. This will save you time on the short and on the long run, but it is important in the short run as well. Sometimes you need to know what integration pattern between services you wanna start with, at least async, synchronous. Define some general rules, and all of the service will be able to follow that kind of patterns. Some infrastructure, of course, you need to make some decision ahead of time. Pipelines, but those are later on. But for infrastructure, how are you gonna host it? How are you gonna run your services? Decision that you need to make straight away. And I would say most importantly, observability. Get all of your standard and common like piece of information you need as soon as possible. So all of the services will just need to comply to it, right? You don't want to discover later on that each service is logging or is tracing in a different way. You cannot really figure out what is going on in your systems. So do it as soon as possible, and then it's just a rule book for every team to follow. What are the common patterns out there you can use? Well, some of the most important and most common one are the one described here: parallel run, branch by abstraction, decorating collaborator, CDC, and strangler fig. So I'm gonna spend like 1 minute probably on all of them, and then we're gonna go into straight to the technical and see one of those patterns or a couple of them in a real scenario, let's say. Parallel run, as the word say, is a pattern that allows you to develop microservices alongside your monolithic application. They're gonna be run side by side, and usually those are this pattern is chosen to have confidence is what you're gonna deliver is gonna have a feature parity, right? You're gonna run both of them at the same time. You're gonna compare their execution, the results, and only when you're satisfied with them, you're gonna decommission the monolithic feature that you need. Branch by abstraction is a pattern that is involved within the monolithic application. You are creating an abstraction layer and within your monolithic application, and that will allow you to start replacing and gradually changing, piece of your monolithic application. As I say, these patterns are not one or the other. They can all be mix and match, right? Depending on your needs. Decorating collaborator, this kind of stand out a bit more, is one of those patterns that allow you to introduce microservices, not as a replacement, a direct replacement of a monolithic feature, but as an augmentation of that. Let's say that you have a monolithic application and it returns you data A, B, and C, and now you also need another piece of data as part of a resource, for example. Instead of like making a lot of big changes to your monolithic, you might have like a new service that is going to collaborate on it as the decoration part, the name comes from. So the request is the same, the response is going to be enhanced. CDC, change data capture, is usually at the database layer. Is a great pattern when you need to propagate data across microservices. Now, each microservice will have its own data persistency layer. The change data capture will allow you to capture changes happening in almost real time in the data storage of your monolithic application and propagating those changes to the right microservice that you need. And last but not least is triangular fig. That is, if you heard about it, it's just a pattern that allows you to replace a piece of functionality with a new microservices, and you do gradually. If we go into it, so how does it, when you choose a fig pattern, and why we're going to see that one now, is quite powerful. Is allow you to, is needed when you potentially want a gradual migration of functionality. And in that case, you have like a system or a monolithic application that by size and complexity would make a big bang release too risky, right? So if that is too risky, this is a great pattern to choose. It's a great pattern to choose if you want to minimize as much as you can the end user impact. Sometimes having a user be impacted is part of the game and is acceptable. Sometimes it's not. In that case, you cannot go for a big bang, aka you need a gradual approach. This is a pattern to choose. And another reason to choose the triangular fig pattern, of course, is if you want to deliver a new feature without waiting for the entire transition, right? And a full transformation of your, a full digital transformation of your monolithic application into new microservices. You can just do piece by piece, pick the new feature that you need to deliver, and bundle potentially that feature with some of the old feature that you want to decommission, right? And bring it across. So how does it look? Well, a lot of time these patterns are big names, but what in the end of the day is potentially something that you already done it, or maybe not. So on the left-hand side here, we have a big boy, our monolithic application. This is actually what we're gonna see changing in the code. So we have in the big boy here, we have some models, data models, right? We have a stock, product, account, user, shipping, and addresses. And we have a new requirements. We want to take out stock because we need an inventory service that will do more than just stock information, right? It will just be the starting point of like a full warehouse set of services. So how do you do that? You will do in steps. First of all, what we're gonna do, we're gonna introduce a reverse proxy, API gateway, whatever you wanna call it, right? We're gonna choose a reverse proxy using Nginx just for the simplicity. We're gonna reroute the request that comes from a user for the reverse proxy straight into the big boy, into the monolithic application. And after that is done, we're gonna introduce the new service, move stuff around, split the network flow depending on the request from the user, and get the results. And the final bit, if we have time to do that, we're gonna see how we can propagate some data that usually or initially was just part of the monolithic. Because to be fair, it's really unlikely that you have a service or an entity that you can just pick it and bring it to a new service, right? Most of the time that has business logic that depends on other entities and other behavior in your system. So you still need that capability to and that integration with system. So I'm gonna come back to this slide as we go, but since we have quite not that much time, I'm gonna go straight into the code. I'm gonna use Amplication for this. Of course, I'm part of Amplication, but that is a tool that will allow me to generate a code that we can see running in a few moments, right? So that will show massively this demo, all right? So let's go there directly. So I'm gonna open my Amplication account. So I logged in, I have my new project. Let's say I already have I have a monolithic application. I did already have a database schema. So I did my introspection in my current database. So I get all of the data entity that I need. So I'm gonna quickly create a shell project in Amplication, and I'm going to import that schema into it, right? So in this case, as you can see, it's completely empty. I don't have any entity. Entity for us is a data model. I'm going to import a Prisma schema. I have my monolithic Prisma schema here. Amplication will of course, doesn't know about your business logic. It's going to generate a CRUD set of operation that could be GraphQL and REST API, or either of them, or both. In this case, we imported, as we can see here in the entities, we have all of the entities that I used to have. We mentioned, as I said before, we had the stock. If you remember, the stock is going to be moved to somewhere else. And it does have a dependency or a relationship, actually, in this case, to a product entity, right? So these are still stuff that we need to take care when we are working on this kind of migrations, right? Before I generate the code, I'm gonna just do one thing. I'm gonna select my authentication entity. This will allow me to log in, so make authenticated request to my service. And I'm gonna install an authentication plugin for achieving that. So I'm gonna use a basic auth, username and password, so we're gonna be easy peasy. And this is gonna be running. So as this run, as you can see, there are going to be quite a lot of changes, right? We had 136 changes because we are creating pretty much all of the CRUD operations for all of these entities, right? And each entities need to have DTOs. Of course, the code will be quite big, right? The first generation will be pretty big. What is the expectation of this? We're going to see the generation happening and a new pull request be pushed to my repository. It's not Amplication repository, it's my code. That's why I'm using Amplication. Go directly there. And this is the current repository I'm choosing. I already connected it just to simplify and speedify the process, okay? Right now, as you can see, there's nothing, just a README and a git ignore, no other branches. And let's see, as it goes. By the way, just to give a bit more context, you can synchronize this with whatever repository you want. We support multiple providers, but this will be like a more sales pitch. So I'm not gonna into those details yet, or today. So let's give a bit more time for the Git pull request to happen. Here we go. It did happen. We have our first pull request in this repo. As you can see, there are quite a lot of files, I would say. I'm gonna merge them straight away, and we're gonna see them as we go, because it will take too much time to explain all of the things. Let's go in our code, and let's pull down. All right, and now I choose, if you notice, I was really fast, but if you notice, I choose monorepo approach when I created a service. That will allow me to have multiple services in the same repository, so it will be easier for us to see. Plus, I'm a big fan of monorepos for people that know me. So we generate, or Amplication generate an MVC application. So you always have DTOs, models. You have a repository layer through ORM called Prisma. And you also have, for each of your entities, you're going to have a controller and a resolver. Controller for REST, resolver for mutation and queries in GraphQL. Okay. So what we do right now, we have our application. So before I jump into it, I'm just going to run straight away our classic npm install, because Amplication also generates the package JSON for you. So is ready to start. And following, I know by the back of my hand right now, but when you follow your instructions here, you will do the Prisma generation. This will allow us to create a client for our repository layer. Then you can start your Docker. I'm not going to start it because I have it already running with the database and everything with some data, just to, again, to speedify the process. And I'm not going to initialize it because otherwise it will clean them up. So the thing I'm going to do, I'm going to start it. And when I start it, I can start both the front end, and there is also a UI that we use. This is just for us to have something quite quick. Let me bring it here. I don't know why it showed me a different page. Okay. And in here, this is actually this UI. I'm already logged in. Let me log out again just to see. I'm logging here as admin. Really great password. But anyway, what it's gonna do, this is UI is a single page application that will call GraphQL, our service, and get the data that we see on the screen, right? So CRUD operations, and this will allow you to do pretty much most of it. If we go to the server APIs, we by default generate also the Swagger for you. And of course, what we're gonna do, we can get the Swagger definition. So you can import it into whatever you want to import it, and you can just start using it. Even a generator, right? Okay. So before I go forward, what we're gonna do, we're gonna add some custom code, right? I get some pre-made patches so we can see directly the changes. So let's assume these are our fake changes, like this is the business logic, right? Important ones to see are changes to the stock service, where we have new methods. What we care about right now for the sake of this is a report. So I'm going to have a new feature, a new endpoint that will return me a report and a list of all of the stock in this format. A controller that will expose some actions, right? A post endpoint, another post endpoint. And what we really care is this get report endpoint to get the data that we saw. And then in the shipment is our business logic that we spoke about before, when you have connection between different things. Every time that you create a shipment, well, you want to decrease automatically the stock. As easy as that. So let's commit all of that. Custom. One more thing before we run the application, I'm going to also add some other custom code. In this case, I'm going to create a middleware. I already created here a middleware. Middleware we use Nest.js as a framework. Middleware works exactly like Express. When you look inside this middleware that happen in every single request to the server, we will just log it. Simple as that. Just to visualize what's going on. And the last change here is to add to the report endpoint an header, a response header, just to tell us that it's coming from the big boy, right? That's pretty much it. So if we do log, we commit log, great semantic commits here. Anyway, hopefully this is already up and running. Let's do import it. So I'm going to open Postman, and I'm going to delete my previous one. I'm going to import it, and here we go. I did something wrong. Local hosts 3000, and then we have API JSON, right? And this is the magic URL that will give you the definition. Import it. It's importing it. Here we go. Nice and fine. Look at that. We have our report. What we want to do, well, first of all, we need to have the variable set up and the authorization coming from the top, so we don't need to take care of it. So authorization, we say is basic auth, admin. Variables, we're gonna do HTTP localhost 3000. Save, close, run. Boom. This is calling. We're gonna see that. We call the big boy monolithic application. there you have already everything, right? This is your monolithic application. And in the header, you can see that is coming from the big boy. So now let's do the first step of your fig, Strangler fig pattern, right? We're gonna create our abstraction layer. So our, in this case, our reverse proxy. So we're gonna, again, I'm gonna apply my reverse proxy patch. What is it? It's nothing else than a new Docker compose. They use Nginx, one of the most famous proxy out there. And we will gonna configure Nginx as our as per our needs, and we're gonna expose 3100 port, right? So to speak with that, we're gonna use 3100. There is a package JSON just for me to click the button, and this is the config that we're gonna touch. So what does this mean? It means most important here, we have add header. That means it's gonna add a response header, says that is from Nginx and the value is true. So we finalize and we say that everything is what we expect. Then anytime that we call localhost 3100 / GraphQL, the request will be proxied to this URL. I'm gonna run the server, or I'm running actually the server on my local machine. This will be running in Docker, so I need to get to the host. So I need to go out of the Docker network into my host machine. That's why I'm using the host internal DNS name. And the port is the 3000, that is the port that we expose. They can find it in the environment variable. Here. All right. So let's go back. One final thing. Same we do for APIs. So GraphQL is for the GraphQL endpoints. Of course, APIs is the format that we use. API, stock, reports, API, shipment, and so on, so on. So let's start it up. So I'm gonna run this one like this, and this will create my my new container, right? We're gonna see that one. Here we go again. Now container running, all good. And now we're gonna try to go through the container. So now we are acting, my postman is acting as the client, the user. The client application needs only one change and will not see any changes, right? So I change the URL, go back to the same URL here, 3100, send the request, same response, go back. You need to trust me on that side. On the headers, you can see that the service name is still Big Boy. And now we have from Nginx through. So we know that it's coming from Nginx. We can also see from the logs here and from the log here, right? All right, first step done. Now, what's the next? Well, next is doing actually what we need to do. Take out some functionality, right? It's taking stock out from here and bringing here, right? Let's do that. So I'm going, again, if you do it manually, you will probably create a new application and so on, so on. You will copy the code, create DTOs, everything. I'm gonna use Amplication just for simplicity. I'm gonna go into architecture. That's my monolithic application. I'm not gonna use the AI. I wanna do monolith because I know what I'm doing. I don't need help, he says a few minutes later. I'm gonna create my inventory service. And I'm gonna simply move the stock here. That's it. Apply the plan. This will tell me you're gonna create a new service and the stock will be detached from the other entities relationship, right? Into the new one. Yeah, let's do it. That's what I want. Is what I want you to help me at. Okay, then we got it. So let's have a look. This is gonna generate the code. So that's the first change. As you can see, we have 11 changes in the inventory. We have the stock information. As it does build, I'm also gonna announce and create another generation because I want to add the same kind of states that we had in the monolithic application. So what I want to have an authentication in place so I can make authenticated request. I'm just gonna create a user entity as well, because it will hold my user information, admin for now. And then I'm gonna set it up. So that's my authentication entity. So how does it look? The inventory service, as simple as two unrelated entities or data models. A user for me to log in, stock, what we really care about. And at this point, I'm gonna generate this. Now, as you can see, the first change already happened. We have a new pull request here. I'm not gonna merge this one. I'm just gonna wait for the second commit when I click the generate again, right? But let's see what changed here. So a lot of files, as we said, what we care about when we're gonna look into it is the inventory stock. We have our stock, and in our stock we can see controller, as we said before. Again, those are the CRUD operators and CRUD endpoints that we define. So we will need to bring across now the business logic. We have also our base, right? And when you look at the service, if you were asking where is the magic, how do you get the data, is in the base, right? We expose counts, all of the CRUD operations out of the box. Now I'm going to refresh here because potentially a new commit happened. I'm pretty confident that was the case. Yeah, as you can see here, the new generation happened. So let's go back in commits. And now the second commits potentially is going to only have the authentication information. Let's say this one. Yeah, we're going to have all of the auth side, as you can see, auth, and all of the auth information. Nice. Gonna merge it straight away. We cannot really lose much time here. Same will be with the big boy, by the way. So let's merge this one. And let's go into our source code and let's pull from main. Oh, I forgot to commit. Reverse proxy. There we go. Of course, I'm doing everything in main. You will not do that. I'm sure that you will not. That's not good. Well, I'm not going to do that for now because I will probably create a pull request, all of the normal. So I just pulled. Let's close everything just to have a bit of a cleaner state. We have the inventory here. Now we have our stock. Okay. So what I'm going to do, I'm going to apply my change where I'm going to migrate the logic. And what is going to change? Well, let's have a look. First of all, it's going to change my port just because I already have the monolithic big boy running on 3000. So I need to have a different port for it locally. I'm going to also change the database because I forgot to do it in application inventory. Otherwise, you would probably do in the plugin setup. So I'm going to do that one as well because I do have already a database called inventory, as you can see here. All right, with the data. Then what else is going to happen? Well, it's going to create the same information, almost the same business logic that we had in monolith in the service, with then one exception. You see here, this product name is hidden, right? It's not going to be returned because now in the microservice we don't have product name. We'll only have SKU, and this is a great opportunity to just filter out information that you don't need. If you definitely need this one from the report, then you will need to bring this piece of information and have like a potential local cache in your inventory, right? Local cache means a new, like a database, like that could hold this information. Doesn't need to be a cache. And in terms of like services, again, we have another inventory change. Of course, the service is what we saw before, nothing new. Mapping, reporting. So what I'm going to do, I'm going to go and run our npm install. I'm going to stop the gateway for now because I want to show also a different change. So as this installation go on, let me open this one in a terminal. There is also another change. So what I did when I applied the change, I pretty much removed the comments from this line. And this one will tell Nginx to say, okay, any request that is /API/stocks go to this other service, not the monolithic. And here is where the magic happens, right? Because your client doesn't know that, but it's gonna get result from a different service. Since that is done, I'm gonna do run stat, and this will do apply. Will apply this change as well. In case you need, like, let's say you see I didn't change GraphQL. GraphQL is a bit harder to do in this way with a reverse proxy. You're probably gonna choose something that is more relevant to GraphQL if you need to introduce this kind of pattern. Probably like a federation gateway is a great way to do it. There is, of course, a version from Apollo client server and a version from another open source solution. I don't remember the name right now. I'll post it if I remember. But yeah, you might want to use something like that, or you might want to have like a custom solution that just depending on the query will send you, or the header will send you to wherever you need to be. Okay. So right now, my inventory is not running yet. So if I go back here and I try to call the report, I'm gonna get a fantastic 502 because the service is not running yet. So let's run it. npm run. We need to generate Prisma first, and then we can start it. And now what we used to see in the headers was big boy. Now we're gonna see the new service inventory. As part of that change, I forgot to mention, but as part of the change in the inventory, we also have our common header with the inventory, right? All right, so pretty much this is it. These are just the starting point for you to start exploring new solutions, right? But let's spend like 5 more minutes for the second piece, right? The thing when we have a dependency between actions and now we are in a different service. So we introduce Kafka, we'll emit an event. In that way, we will have 2 different services, a monolithic application and the inventory service that will be independent. And if one of them is down, the other one will not be affected because the asynchronous architecture will handle it, right? Only when one is ready to push or to listen, it will do the action. So it's gonna be pretty, resilient. So let's go back to our system. Now I'm going back to Amplication. So let's go here. And I'm going to create really quickly a message broker, generic message broker at this point. And in here, I'm going to create a new topic, right? You don't have to, but I'm going to. Just to make stuff a bit more relevant. I'm going to also change the inner name of the topic because I want to version it. So create one new topic, go to my big monolithic application. They will need to change a bit. So I'm going to connect it because I want to have my monolithic application to be a publisher of events. So I'm going to send events to the shipment, logistic shipment topic. And I'm also going to install a message broker plugin, Kafka in this case, really like Kafka. So, and this will generate for me a lot of stuff. I'm going to speak about those changes in a second, but I'm going to do the same for the inventory, right? Plugin, or Kafka, you can get it from here, less clicks, and good connections, logistic, and I'm going to listen to that because we need to listen and change the stock level. Now let's generate. So why did I choose this one instead of like writing code? Well, because I know that this one will generate pretty much everything that I need to be able to put my business logic in. And this is what I want to do, right? I want to add my business logic, I don't need to reinvent the wheel. It's something that you probably do a lot often, probably copy from a different place, copy and paste, then you need to rename it. No need, just let him do that. So the changes here we can see, we have a new Kafka plugin. I haven't chosen the version, you can choose the version if you want. So it's gonna be the latest version of the plugin, usually the one with the most bugs resolved or new feature, right? And same for the other one, new message broker connection and the Kafka plugin. So let's see. All right, this is already ready to go. Let's go in my new pull request, and we're gonna see 13 files, and those are just Kafka, right? We have Kafka changes, so we have our Kafka broker. I have already Kafka running on my machine. As we can see here, I have Kafka running, right? So I'm gonna use that one, 1992. I'm gonna have for this service, client ID and everything that we need. We're gonna have a Docker compose for you to, or for us, for me to work locally if I didn't have that set up previously. And I'm gonna have new dependencies, right? So of course, I'm gonna merge this and we're gonna see the actual, oh, 1 second, let me resolve the conflicts. Now there is a conflict because Amplication didn't know that I changed the port, so no worries. I'm gonna just resolve the conflicts very quickly here. And I'm gonna resolve it, commit it, and merge it. So I want to keep keeping like 3002, right? And merge and merge. So now same would be happening to the monolithic application. Yeah, let's go there. There are more changes because I forgot to merge before, but they are the same. There is a tiny difference that we're gonna see in a second. Let's see if we can merge it. Of course, we cannot because we add custom code. So I need to resolve the conflicts. Let's resolve the conflicts really quickly. Yep. So yeah, it doesn't exist anymore because of the strangler fig pattern. The stock service and controller don't exist anymore. So they got deleted. And in here, we are not gonna have that one anymore. And we are not gonna have, we're gonna have the middleware. Oh yeah, sorry, my bad. Yes, we're gonna have the middleware. Second. Up. We're gonna have the middleware, so we're gonna have this one and no stock. Yeah, resolve. Okay, commit, push. And now I'm going to merge it. And we should be able to in a second. Did I push? Okay. Here we go. So let's merge it now into master, and then we plug in the last piece of the demo, and then we good to go. All right. So let's now go back to our Visual Studio Code. I'm going to do a git pull. All right. So let's see. Now we have stuff that is broken. Of course, I need to install the new dependencies in my services. Okay, nothing changes in the gateway because there is no communication for the gateway. Now we're gonna apply our last change. One second, what did I do? Oh, I forgot to pull. I'm not in master. Yeah, there we go. Here we go. So I applied the last change. So what does this do? So what we need to do is to emit the event instead of doing what we used to do. So we are adding Kafka. So we are adding a schema in our big boy in the monolithic application. I'm adding a schema and I'm leveraging what Amplication give me, a Kafka folder for me. This contains a controller that has no event handler because it was not listening to any topic, right? And a producer that will allow me to quickly send Kafka messages. So you just interact with this abstraction. And in our shipment, I don't know if you remember, but we used to have here, when the order was shipped, we used to have a change. Actually, we can see in here. We used to have an update to the database, right? Now we're not going to update the database anymore. We're just going to emit an event. And then, of course, you know, it needs to be almost real time because of stock information. But this is a silly example that came out with. So it's going to generate a new event in Kafka containing information about the shipment and the quantity and SKU of the product that we're shipping. On the other side, inventory, we are going to have some, let me open it and stuff that is more readable. Here we go. We're going to have at least one event handler, as we can see. This is all done for application for me. Nice. I'll put my logic only. And the only logic I'm going to put is this one, right? I need to call a stock service for every time that I get, you know, a shipment topic, a message coming through. I look through the order items, so to the products that can be shipped, and I'm going to update their stock, registering a goods out operation, quantity and that. And the other change, of course, is going to be in the module here, because it needs to import it. That's just Nest.js. All right, so let's run this. I forgot to the npm install on one of the service. Yeah, on inventory. Let's do npm install here as well. Okay, and we are going to run it. So pretty much everything else is the same, so I'm not going to touch it. Just going to run it, hope for the best. I forgot that I also need to regenerate Prisma, of course. Okay. And my bad, I probably have mistyped something. Here we go. Let's go in here. In fact, on this side as well. There we go. Let's run Prisma. And then let's run our final piece of work. That is our inventory. Here we go. So now we have both of them running. We look into my client. I can see there is a new topic, logistics shipment, right? And there are no messages. So the last thing I'm going to do, I'm going to use again my Postman to make a shipment. I already have a shipment here. You need to trust me on this side because it's the data that I've selected. But when we look at the report right now, this is coming from inventory, and we can see here that we have 2, right, as a quantity of 11, 12, 34. I'm going to create a shipment that is going to ship the order item with this ID that is actually shipping 11, 12, 34 with 5 units. Now, we are not validating anything right now, so I'm just going to create this. This was created successfully, created. Now, let's have a look to our Kafka topic. If that is there, it means the big boy, the monolithic application sent through your order or your message. And we can see here, we have one item, 11, 12, 34, unit 5. So now we expect, if I go back to my Postman, I'm expecting here to have this one, I guess, -3. Yeah, we are in debit. So let's run it again. -3. So this, how everything was connected, right? So this is a silly example. It will show you how you can achieve that, separation as well between services once you start splitting out stuff. And yeah, that's everything I have to show. So if there is any question, feel free to put in the chat. If we don't see any question, we can just go ahead, and you can always reach out to me. So I'll leave like a couple of minutes here if anybody has any question to add. Otherwise, if they're gonna be added later on, we will be replying by email or something. Oh, I just got told that I just got told the chat was disabled. So there is a section in the Zoom controller for Q&A. That is potentially the one that you want to choose. I don't know. There is a chat and Q&A. Chat is disabled by default in webinars. So Q&A is the way if you have something that you want. Anyway, that was I don't know if it is good. Hopefully, I did not bore you too much actually. But anyway, if you have any question, if you wanna hear like more about it, if you wanna just speak about this kind of topic, just let me know. Let us know. If it is something application related where we can help. Of course, you have the contacts here on this page. You're gonna have in a moment. Here we go. QR code. I'm gonna put my details in the chat as they're gonna be shared, but it's easy. It's my name at amplication.com, or you can find me on GitHub under at Overbits. So feel free to reach out to me, to reach out to Amplication, and yeah, thanks for joining once more.